All right, so last lesson, we looked at relative extrema, which is to say, where are you taller or lower locally, like higher than the points around it or lower than the points around it. But now we're going to talk about the absolute. Sometimes we want to know, I just want the biggest. I want to know where Mount Everest is. I want to know the tallest, the highest, the absolute maximum, the biggest number. I want to know how you're going to get the most profits. I want to know who is the tallest human on the entire earth. I want to know the absolute max or min of something. And so here's how we're going to do it. Oftentimes it's over an interval, most of the times. So that will be like 90% of the time you'll be given an interval. Okay, so if you're 90% of the time, there's an interval. And 10% of the time, the interval might be negative infinity to infinity, okay, for like the entire range. Okay, so the end idea is the maximum, okay? It either occurs this is if you just think about it for a while. I'm not going to prove it to you because we don't really prove that many theorems here in AP Calculus, but I want you to think about logically. Either the maximum can occur at a relative min or max, or it's the endpoint of an interval. So let's take a look at this graph, and let's say this is the endpoints here. Where is the lowest point in this interval would be right here. This would be the absolute min. Where would the absolute maximum be? Well, on this interval right here, this would be the absolute max over this interval from there to there. Okay, so this is the key idea, is that the very largest value or the very smallest value will either occur at the local mins or maxes, or it'll occur at an endpoint of the intervals. Okay, so is it true that it always has to have absolute min and max? Maybe. Sometimes it may not, in which case, now we're going to talk about the extreme value theorem. When do we know for sure that absolute min is max? This is a theorem that's not often asked on the AP exam, but it is good to know and good to use. It will show up on some FRQs rarely, but it does happen. The condition is that if the function is continuous over the interval, there's nothing weird happening, it's not jumping around or things like that, then it definitely has a maximum and an absolute minimum on that interval. So when would you not have a maximum interval? So let's say I had a function that did this. It just shoots up forever. And then it starts here and then goes down like this. And then I tell you, well, in this interval, right, you might have a minimum over here. Like this might be the lowest y value, but you won't have a maximum over there. Okay, so and that's why that's continuity is such an important condition. If it's continuous, you know for sure there's an absolute min or a max. But if it's not continuous, not necessarily. So unless they ask you to use the extreme value theorem, or they ask you when is there for sure an absolute min or max, you don't necessarily need to invoke the extreme value theorem, but that is when we definitely occur. So a lot of times when you're going to be asked what is the maximum, implicitly what defined in there is that it is continuous. But in general, if it were not continuous, you don't necessarily know that there's going to be a min or a max. Now, to actually find the min or max, we use what we call the candidates test, and it's the way we find the absolute min and maximums. Now, a lot of students confuse this because the process is very similar to finding relative mins and maxes, but it's slightly different because I'm looking for something different here. Because the reason it's similar is because the min or max might occur at the endpoint. It might occur at the relative mins and maxes, so I still have to find those locations. So it's very similar to the first derivative test, which is why students confuse one. So first step, we find the critical points. That's where f prime of x is 0 or undefined. Now, if I have multiple relative minimums, how do I know which one is the absolute minimum? Well, what you're going to do is plug in to the original function and just see which one is the smaller value, right? So we're going to evaluate f of x at the endpoints. Notice there's no number line here. It is not necessary to do the number line because I'm not trying to classify it. The way I'm going to find the minimum or maximum is just say which one has the largest y value, which one has the smallest y value. It's just the critical points and the end points are the possible locations where that absolute min and max may occur. So the largest value is the absolute max and the smallest value is the absolute minimum. Okay, so let's take a look at some examples here. Find the absolute min and maximum value on a given interval. So here we're going to use the candidates test. We're going to first find the derivative and set it equal to 0. So 2x plus 1 set it equal to 0, x is equal to negative 1/2. Now we want to make a table to evaluate the value of the function, not the derivative. I'm not evaluating the derivative. The original function, I want to include the endpoints and any critical points. Now, the critical point needs to be within that interval. Like if this number were outside of the range from -1 to 2, then it doesn't matter because I'm not interested in any critical values outside of this interval. Okay, so now we're just going to plug in -1 here. So f of -1 would be -1 squared minus 1 plus 4. That's going to be 4. F of 2 would be 2 squared plus 2 plus 4. And that's 4 plus 2, 6. 6 plus 4 is 10. And then f of -1/2 would be -1/2 squared plus -1/2 plus 4. That would be 1/4 minus 1/2 plus 4. That's going to be, let's see, minus 1/4, 3 3/4. Okay, like this. So this is the smallest value of the y values, smallest. And then this is the largest. So that's the maximum, and that is the minimum for that function there. Okay, let's do another example. Let's look at this one over the interval here. So first, f prime of x equal to 0, because we want to find those critical points. Here we're going to do product. So first we're going to make this x squared, make this, remember with radicals, we want to do it like this. We're going to do product rule. So derivative of x squared is 2x times 8 minus 2x squared to the 1/2. There's a lot of ways to do the derivative. You don't have to do it my way. There's actually a lot of ways to do it, but this is the most direct way I would do it. Then x squared times the derivative of this would be 1/2. This is going to be power rule. Subtract 1 on the exponent. Derivative of the inside would be minus 4x here. Okay, so then this is 2x, 8 minus 2x squared to the 1/2. Let's simplify this one. Minus 4 times minus 2 is going to be minus 2, and then x times x cubed. 8 minus 2x squared to the negative 1/2. This is a cool trick to solve for when it's 0 or undefined is I'm going to factor out a 2 and an x, and of these two terms, I'm going to pick the lower exponent. So this is a little bit of a trick. The smaller exponent is what you factor out. And so over here, what times this is going to give you this one is going to be 8 minus 2x squared to the 1 power, because 1 minus, you would add those exponents. 1 minus 1/2 will give you 1/2. And then here I pulled out a 2x, so there's only an x squared left. And then I pulled this guy out, so there's none of that left. This guy simplifies into 8 minus 3x squared. So then you can simplify this to 2x times 8 minus 3x squared divided by the square root of 8 minus 2x squared, like that. And we want to know whether this is 0 or undefined. Okay, so then 0 is when the numerator is 0. So that would be x equals 0. This term is 0, or this is 0. And this would be x is equal to, well, let's see, do 8 minus 3x squared is equal to 0. That means 8 is equal to 3x squared. Then we would get x squared is equal to 8/3. So x would be plus or minus square root of 8/3. And then finally, this one down here, 8 minus 2x squared is equal to 0, where it's undefined. That would be x squared is equal to 4. So x is equal to plus or minus 2. Now, we're only doing the interval from 1 to 2, so I don't care about the 0. I actually don't care about the negative square root of 8/3, because that's outside of the range. And I don't care about negative or positive 2, because I've already, that's the edge of the, I'm going to include that anyway. So the only one I have to consider here is x equals square root of 8/3. And that is like something like close to 3, a little bit smaller than 3. So that one also not going to matter either. So it turns out I don't need, none of the critical points I found are actually necessary. Actually, I'm mistaken. This number is less than 2. Sorry, 8 divided by 3 is almost like close to 3, but square root of 3 is like 1.7. So this one is a critical point. So then we want to make a table here. All right. This one might have been more like a calculator question, so I think that would be okay. But we'll just do 1 and 2 and square root of 8/3. Let's plug that in. If I plug in 1, it's going to be 1 square root of 4, no, square root of 6. Yeah, I think we'll use a calculator on this one just to make it simpler, right? So let's just, and we'll just see the graph at it, because this is just practice, right? 8 minus 2x. So you can see already from the interval from 1 to 2, we have a largest value here. But let's evaluate f of 1, f of 2, and f of square root of 8 over 3. And so we have values here. F of 1 is going to be 2.449. F of 2 is 0. And this is 4.355. So this is our max, which is probably around here. Oh, there it is. And then here's our min. You might think like, well, Alan, you have a calculator. Why don't you just use the calculator? Well, you don't always get to use the calculator. And two, what if it wasn't an exact function or it was a variable or something like that? You need to understand the idea. But you can see we get the correct number there because it's at the critical point right there, like that. Okay, let's look at this one. Which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum on the interval? So which one's guaranteed? It's just whichever one is continuous from 0 to 4. Tangents, you got to remember your tangents. Tangents actually go undefined at points because it's sine over cosine. Wherever like pi over 2, which is like 1.6 something. No, 1.7. 1.3.1, I don't know, 1.6, 1.7 in that interval has a vertical asymptote, so tangent doesn't work. Inverse tangent, so it's, your tangents look like this if you don't remember. Inverse tangent is rotated or flipped, not rotated, it's flipped. So that is continuous, so that one would be good because it's continuous. This one has some denominators. Right, this would be x, so it might not factor, or it might not be continuous, right? So this would be x plus 5, x minus 4. So that's so the denominator might be 0 at negative 5 or 4, in which case like that endpoint is just out of the range, so it's not continuous right at 4. And then here e to the x minus 1 might be 0 at x equals 0. Right on this point is not continuous. So B is the only one for sure that we are continuous over the whole interval, and that's why it's guaranteed. Now, that's not to say that those won't have mins or maxes. Okay? But we're not asking which one of these have a min or max, which one is guaranteed, and guaranteed requires that it be continuous. Okay? So it's not, don't graph these and say like, hey, this one has a max, this one has a min. That's not what the question is asking. They're asking which one's guaranteed, and the extreme value theorem, the condition is that it is continuous in order to be certain to have an absolute min or max.